Okay, you're listening to lesson 13.7. 13.7 is we are going to display data using a stem and leaf plot and a histogram. Stem and leaf plot and histogram, so two different kind of data displays here. So let's start out with stem and leaf plot. What's a stem and leaf plot? A stem and leaf plot is a data display organized by their digits. Okay, 3 different steps to make a stem and leaf plot. Your first step is to create the stem with your leading digits here, okay, with your leading digits. Then you're going to create your leaves. That would be your ending digits, your last digit in your number. And the last but not least, don't forget to create a key. Create a key. So we're going to make a stem and leaf plot for the following data here, a stem and leaf plot. So how we do this is creating a stem. So stem would just be one big bar here. And on the left side here, we're going to have our stems. Our stems is our leading digits. So in other words, our 10s and our 20s and our 30s. And it looks like it only goes 10, 20s, and 30s. Okay, our numbers are all in the 10, 20s, and 30s. So that means my stems here are going to be 1, 2, and 3. Okay, so being that those are our stems, which is the 10s digit, now I'm going to do my leaves, which is my 1s digits, or our last digits. Now the thing about your leaves here, they also have to go in order just like your stems. Okay, so we're going to pick out all the numbers that are in their 10s. So our first number in our 10s, let's actually just circle them. We have a 12, an 18, a 17, and a 10, and an 18. Those are all in their 10s. But we have to put their leaves, their last digits, in order, and then we have to space them out in a way that they don't kind of all blend in either. Okay, so there's some specific rules here. So smallest number of the 5 tens digits here is your 10. So I'm going to put a 0 here, meaning that this is my leading digit, my 1 in their 10s, and this is my 0, my second digit, my last digit, so this 1, 0 represents 10. Our next smallest, our next largest, I just should say, is 12, so I'm going to put a 2 here. Make sure that's not right by the 0, but enough space. My next biggest is 17, so I'm going to put a 7 here. And then I have 2 18s, so I'll put 2 8s. So basically this means 10, this means a 12, this means a 17, an 18, and an 18. Okay, my 20s then, let's see, we have a 26, a 26, and a 22. So I'm going to put a 2 first, and then a 6 and a 6 to represent the 22, the 26, and the 26. And then last but not least, my 30s, put a 1 and a 4, my 2 last digits to represent 31 and 34. Okay, so basically that's what a stem and leaf plot is. Then you got to create a key. So key meaning this doesn't look like it has any labels on it, but pretend it's money, who knows. Okay, my key would be, in my key, if I put 2 stem 6, this means it's 26. That way someone looking at this would look at 2 stem 6, they know that that number means 26. Okay, I'm going to hypothetically throw something in here. I'm going to add another data point in here. I'm going to add the number 59. Okay, considered an outlier. An outlier may be a new terminology that you hear, but I'm just going to throw this in. An outlier would be a number that doesn't quite fit in the set of data. Okay, it's really, really, really big from the data set or really, really small. In this case, 59, it's really large compared to the biggest number, the second biggest number in the data set, which is 34 here. Okay, so if I wanted to throw 59 into my stem and leaf plot, I cannot skip numbers on the stem. So in other words, I would have to have the 4, but there would be no leaves here because there are no numbers in their 40s. And then I would add the 9, meaning 59 is our last number here. Okay, so this is hypothetically saying if there are numbers in the stems that were skipped, you can't skip them in your diagram. They just are left there, but then there's no leaves that go with it. Okay, and a good way to check that you've hit all the data points, one checking point that I like to do, I count my data points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and in this case 11 because I added an 11th number. I make sure that I have 11 leaves in my stem and leaf plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, just to assure I didn't forget a data point. Okay, so a stem and leaf plot is really nice to actually put numbers in order to see the smallest number and the biggest number, Makes it easier to find the median and the mode because you can see, well, I have two 26s and two 18s, so my mode in this data set would be 26 and 18. It makes it easier to calculate the median because the numbers are in order here. Okay? All right, so that brings us to our next data display. I'm going to delete that. What a stem and leaf also helps us do is to make a histogram. So let's scroll down and let's take a look at what a histogram is. A histogram is a bar graph that displays data from a frequency table. Okay, it's a little bit different than a regular bar graph. It's different that it uses a frequency table to display in a bar graph. Okay, so here are the steps. To make a histogram, your first step is to choose intervals of equal size. Okay, intervals obviously bigger than 1. Okay, so 2 are larger, intervals of 2 are larger, because if you just have intervals of 1, then it's just a regular bar graph. It's not a histogram anymore. Second step, you need to draw your bars for each interval. And then third step, make sure you have labels on your histogram so we know what the numbers mean. Okay, so in the case of our example here, there's no labels on these numbers. These are just plain old boring numbers with no meaning to them. But if they did have meaning to them, we would make sure we label them. But we still have to label our graph anyways. Okay? All right, so keyword here, intervals that are equal size. So we're going to use the data above to make a histogram. And what we're going to do here is we're going to make a frequency table. Okay? So in a frequency table, you get to choose your intervals. And there's no rule that says what intervals you want to go by. In this case, there's no direction to tell you. So we can make intervals as big or as small as we want. Okay, so my rule of thumb is if you have a good amount of numbers, I think at least 4 or 5 bars in your histogram would be best. Okay, but like I said, there's not necessarily anything wrong with less than 4 or 5 bars or more than 4 or 5 bars. Okay, so what I like to do, my rule of thumb is this. I look at my data set and I pick out the largest number. So I'm going to actually use this large number, 59, and my smallest number, 10 here. So 59 and 10, I'm going to find the range, 59 minus 10. My range of numbers is 49 numbers, okay? And if I want 5 bars in my histogram, I'm going to go with 5 bars, okay? I'm going to take 49 and I'm going to divide it by 5 because I want 5 bars. And 49 divided by 5 is about 10. I know it's a little bit less than 10, but I'm just going to say it's about 10. So what I'm going to do here is I'm going to make bars that are intervals of 10. Okay, this is going to be your interval. So what does that mean here? That means my first interval, starting from my smallest number was a 10. Remember that was a 10 there. I want from 10, and then I want 10 numbers in my interval. And I know a lot of you are thinking 10 to 20 is 10 numbers in your interval. It's actually 10 to 19. Because if you count on your fingers, counting 10, that actually is 10 numbers. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I just physically counted my fingers. I know you can't see me, but if you count 10 all the way to 19, that's actually 10 numbers in that interval. Okay, we're going to keep making intervals of 10 here until we can reach our largest number interval here. Our large numbers to fit in that interval is 59. So my next interval is going to be 20 to 29. That has an interval of 10. Even though I know you're subtracting 20 minus 20 is 9. So you're thinking there's 9 numbers in it, but remember you're including the 20. Okay, when you subtract, it doesn't include one of the numbers. My next interval is 30 to 39. My next number is 40 to 49. And my next interval is 50 to 59. And I think that's my last interval because 59 is my last number here. So then what we're going to do is we're going to go up to our histogram and we're going to count up the frequency of numbers that appear in each one of these intervals. So for example, how many numbers appear between 10 and 19? Well, there are 1, 2, 3, 4, 5 numbers between 10 and 19. So I'm going to put 5. How many between 20 and 29? 1, 2, 3. How many between 30 and 39? 1 and 2. Between 40 and 49? None. And between 50 and 59, there is just that one number. So like I said, to make sure that I have the amount of data points. Remember, I counted 11 numbers in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Okay, 11 data points, 11 numbers here. That means if I go down here and I add up all of these numbers, 5 plus 3, which is 8, plus another 2, which is 10, plus another 1, that's 11 numbers. I know I have accounted for all 11 data points in my stem and leaf plot. So let's go ahead and make the histogram then. Okay, in a histogram, you're just going to make your quadrant 1. It's going to be an L grid here. And on the side, it's going to be your frequency. And you only need to take up your frequency as big as the biggest number that you have. So 5 is the highest number I have in my frequency table. So I'll go 1, 2, 3, 4, 5. And then all I'm going to do is I'm going to make a bar for each one of these intervals. I should have 5 different bars because I have 5 different intervals here. Okay, so my first bar is going to be the 10 through 19. So 10 through 19, and I'm going to make my bar 5 frequency high here. So draw it up to 5, and I like to shade it in because it makes it look pretty, but that's up to you. Okay, next bar, 20 to 29 is a frequency of 3. So 20 through 29, I'm going to label this. There are 3 numbers that fell in that frequency. Next one was 2 numbers between 30 and 39. So I'm going to make my bar so it reaches up to 2. 40 through 49 had nothing, so I'm going to leave that blank. I'm going to skip a space to show that there is nothing in there, but I'm still going to label it 40 to 49. And the last but not least, I have my my bar of 1 that represents any number data points between 50 and 59. There you go. That is our histogram. And that histogram is related to our stem and leaf plot that I have drawn over and over again. But these two, even though they give different information, but represent kind of the same data set. Okay? So that would be a histogram. All right. Here is your summary. Stem and leaf plots and histograms help. It's just a kind of a data display that helps us sort and organize our information. And remember, stems and bars should always go in order, even if there's no data to be filled in. So remember that spot we left kind of blank because there was no data in the 40s? You still need to represent that information, even though there's nothing in there. Represent that piece in the plot. Okay. Thanks for tuning in again. and sample is here.